Mr. Ben Chan, who is a Deputy Director of the Survey and Mapping Lands Department, and Mr. Ben Fan, Land Surveyor and 3D Mapping Project, and Mr. Michael Lau, Land Surveyor and BIM of the Lands Department. They will share the initiatives and strategies to support Hong Kong's geospatial information management framework. The latest development of CSDI and 3D digital map. Examples of CSDI, 3D digital map, and BIM developments, applications in other advanced economies, and the insight from the BIM data repository consultancy will also be shared. They will also give a very short introduction of what they will talk about. The topic is geospatial contribution to digital twins for smart city. Governments around the world have started the journey to establish smart cities for their countries for years. The government of Hong Kong SAR is no exception in striving to build Hong Kong into a world-class smart city. Geospatial information is fundamental to deliver benefits to the society and create sustainable values for a smart city. Lands Department as the Land Survey, Mapping and Geospatial Agency in Hong Kong has recognized and understood the changes in the digital era and has continuously learned from international counterparts and organizations such as Ordnance Survey of UK, the Center for Digital Britain, and the Singapore Land Authority on the global trend of geospatial information framework development. To keep up with the pace of international development, Lands Department has taken the lead to contribute to the establishment of the Geospatial Information Management Framework of the city through the development of the Common Spatial Data Infrastructure, CSDI, 3D digital map, and BIM data repository. With that as a background, let's welcome Mr. Ben Chan from Lands Department. Thank you for coming.
Thank you. All right, good afternoon, Professor Honlo and other colleagues. Ladies and gentlemen, thank you to Hong Kong UST for inviting the Lands Department of the Hong Kong SAR government to join this seminar. Today, we would like to share with you this topic, the geospatial contribution to digital twins for smart city. In the Smart City Blueprint 1.0, released by the government in 2017, it mentions the development of Common Spatial Data Infrastructure, CSDI, to facilitate the sharing of geospatial data across government departments and government to business applications, including the launch of CSDI portal, 3D digital map, and electronic submission hub for building plans. In the Smart City Blueprint, released a couple of months ago, government provide updates on the corresponding Common Spatial Data Infrastructure, 3D digital map development, including the preparation work for CSDI portal and data standardization, and also the pilot project for 3D digital map in the Kowloon East area. The 3D map and CSDI could contribute to the development of Smart City of Hong Kong in providing a territory-wide 3D city model holding a rich set of spatial data. Digital technology is changing the way we plan, build, maintain, and use our social and economic infrastructure. We may learn from some other developed countries in the pathway of developing a smart city with digital transformation. The Center for Digital Built Britain is a partnership between the Department of Business, Energy and Industrial Strategy of UK and the University of Cambridge to understand how the construction and infrastructure sectors could use a digital approach for better design, build, operate, and integrate the built environment. In 2018, Center for Digital Built Britain published the Gemini principle to begin enabling alignment on the approach to information management across the built environment. As establishing such agreed definitions and principles from the outset will make it easier to share data in the future. Gemini 雙子星 is a northern constellation of twin, so it makes use of this name to illustrate the principle of digital twin. In fact, it is a group of values set out by the Center of Digital Built Britain to aid development of a national digital twin. The Gemini principle embraces 9 values for developing future digital twins with clear purpose, trustworthy, and effective function. They include the purpose of digital twin. The twin must be used to deliver genuine public benefit. It must enable value creation and performance improvement. It must also provide determinable insight into the built environment. In the trustworthy aspect, the twin must enable security and be secure itself. It must be as open as possible. It must be built on data of an appropriate quality. To make a digital twin effectively functions, the twin must be based on some standard connected environment, and the twin must have clear ownership, governance, and regulations, and it must be able to adapt as technology and society evolve. These are the fundamental values of all digital twins: must have clear purpose, be trustworthy, and function effectively. Such concepts and fundamental values are developed under a notion of data for the public good. Further reference can be referenced from the National Infrastructure Commissioner report of Britain built Britain. This diagram is derived from the Atkins white paper released in 2019 about digital twin for a smart city. A maturity spectrum with 6 elements is used to measure the maturity of a digital twin development, from its simplest form of just reality capture to 3D model visualization map to connect with persistent data such as BIM to real-time data such as transportation flow, existing car park availability, to two-way integration between the real world and the digital world. Lots of elements involve geospatial technology and its digital twin. Now we go on to discuss how we could use spatial data to help smart city development. The Institute for Management Development, in collaboration with Singapore University for Technology and Design, has released the 2020 Smart City Index with key findings on how technology is playing a role in COVID-19 era in a way that is likely to remain. Hundreds of citizens from 109 cities were surveyed in April and May last year and asked questions on the technological provision of their city across 5 key areas, which is health and safety, mobility, activities, opportunity, and governance of a city. Singapore, Helsinki, and Zurich have come top in the 2020 Smart City Index. The Smart City ranked the Smart City Index ranked city based on economic and technological data, as well as the citizens' perception of how smart city the city are. Hong Kong was ranked 32nd in the list. This table shows the ranking of city in the survey. Let's see how we could learn from those world-leading smart city and areas that Hong Kong needs more effort. From the score of individual items, we found road congestion, affordable housing, air pollution, recycling services, citizen engagement in decision-making, and green space are areas that Hong Kong requires more effort. As our topic today is about geospatial contribution to digital twin for smart city, we select some example how geospatial data are applied in these world-leading smart cities. Singapore used spatial data to tackle road congestion. More than 100 datasets of transport are open for use in the analysis of traffic condition, taxi availability, real-time data, real-time road works information, and passenger volume of stations. With open transport data, the public and third-party developers can put them to good use in creating people-centric transport solution. The transport data set that have been made publicly accessible via Singapore Land Transport Authority's Land Transport Data Mall include real-time data on bus arrival time, taxi availability, traffic condition, car park availability. Downloadings of such transport data from the Land Transport Data Mall have increased from an average of 4 million to 600 million per month since April 2015, already 5 to 6 years ago. A number of third-party transport apps have been developed, including the Bus Uncle chatbot. In Helsinki, Maps service show most suitable living areas in Helsinki for families with children. The easy-to-use service provides users with access to real estate listing in the desired area, transport links, as well as much needed information on available service for family with children, nursery, schooling, and recreational space. Helsinki also makes use of spatial data to monitor air quality, highlighting streets with high NO2 values, and maps showing high pollutant areas. Zurich make use of spatial data to support recycling. Recycling map collects over 12,000 collection points for user to identify the location of suitable collection points with different types of recycling materials. Now, we talk about how Lands Department use geospatial data in contribution to digital twin in 3 aspects, including the Common Spatial Data Infrastructure (CSDI), 3D digital map, and BIM data repository. First, we talk about Common Spatial Data Infrastructure. What is infrastructure? Just like conventional infrastructure of the city, such as water, facility, gas and power supply, telecom network facility, data could also be considered as an infrastructure in the modern city. Similar to water, gas, power supply, when infrastructure is set up, you can have the required facility and such as data supply anytime, anywhere. Let me further elaborate why we call data as infrastructure. Water supply by a water truck or gas supplies by gas cylinder are not infrastructure. Until we build a network of water pipeline, gas pipeline, with the water and gas supply from the reservoir or the gas supply company up to the house, every household, anywhere, anytime, it becomes an infrastructure. In developing such infrastructure, we need to agree on certain standards, such as the diameter of pipelines, water pressure, gas flow current, etc. In building a data infrastructure, we also need a set of data standards, a common sharing platform, and even some data clearinghouse. Over 80% of data have their location attribute, which means where is such data is. The value of data can be greatly enhanced if they are referenced with their location, what we call geo-reference or geo-enabled. With different kinds of geo-reference data hosted in the same platform, it supports not only search of the required information, but also information analysis and exploration of new knowledge. This diagram shows multiple datasets, spatial datasets, that are required for the development of a common spatial data infrastructure. We also need a 3D digital map to host the data, to host the spatial data. Spatial data based on agreed standard could be stored, searched, shared, explored, assimilate, and analyzed, serving multi-purposes of different sectors. In the Smart City Blueprint 1.0, I just mentioned, released by government in 2017, there's a chapter on smart government with this diagram showing the generic digital framework for smart city. The digital framework for a smart city is to provide the fundamental technical capability upon which smart city service will be built. Common spatial data, together with big data, open data, are considered in the data layer of such digital framework for smart city. This is the architecture of CSDI platform we are going to develop. We already start some outsourcing work, hiring contractor on such development with some back-end, front-end functions, and inside you could see some repository of fundamental data, spatial database, etc. And some different users can access these data via CSDI portal. "3D digital map is included in the government's CSDI initiative. As I mentioned in previous line, we need a 3D map or 3D city model to host various kinds of geospatial data. Lands Department is developing the 3D digital map in 3 stages, including 3D maps for visualization, 3D maps for unit-based indoor application, and 3D maps for city modeling. The first batch of 3D visualization map, the mesh model, was released as open data to the public on the Hong Kong Geodata Store in December of 2019. By year 2023, the 3D visualization map covering the whole Hong Kong territory and also with some features like individualized, not only a mesh layer of visualization, but individualized building, quite a lot of work on this. And by year 2023, the 3D visualization map covering the whole Hong Kong territory will be available to the general public. More details about such 3D digital map development will be presented by my colleague Ben Fan, who is working on the 3D digital map project on the second part of today's presentation. And another part of presentation today is about BIM development, BIM. Government has planned to undertake various activities for the adoption of BIM technology by multiple departments. Acceptance of BIM format in building plan submission will be handled by Buildings Department and Lands Department. BIM and GIS integration, BIM data repository set up by Lands Department with this prototype or pilot in CDD NDA project, and also collaboration with CIC Construction Industry Council on BIM standard and mandatory use of BIM in all works department. In the technical circular works number 12 stroke 2020, you could download this from Development Bureau website. It sets out the policy and requirement on the adoption of BIM technology and mention about works department shall provide their design and as-built BIM models to Lands Department to facilitate the development of BIM data repository and shall ensure that the model are prepared for the information sharing according to a harmonized BIM standard, which is being developed together by CEDD, Civil Engineers Development Department, and Lands Department in a pilot project for a new development area due for completion this year. This consultancy service led by CEDD on the Kudong North, Kudong Bắc, and the Fanning North new development area define the BIM data harmonization among works department and will serve as a guideline, as the set of guidelines for future BIM data standard in public works. You could see lots of works department participate in this project. The establishment of BIM data repository system would facilitate the sharing of BIM data among different works departments and could also improve collaboration in planning, lands, and works application. The planning and management of our BIM data repository development. Landsd has recruited a professional consultant, quite a renowned consultant, BIM Score, who is experienced and proficient in open BIM adoption and and development to recommend a roadmap of BIM data repository for lands department and government. In addition, data standard, data format, and system functionality, and also proof of concept for BIM and GIS integration are also included in this consultancy. More details about our BIM data repository and other BIM-related projects will be presented by my colleague Michael Lau, who is working in the BIM project management team in the third part of today's presentation. Now my colleague BIM Ben Fan would share with you details about our digital map development. So let me pass the screen for his sharing.
Thank you all for joining today's seminar. And my name is Ben Fan. I'm the land surveyor from the lands department, and I'm now working on the 3D digital mapping project. The 3D digital map, which is one of the building blocks of CSDI, is to facilitate opening up and sharing of government geospatial data. When we talk about 3D digital map, there is an article written by Professor Janten Stolter. She is coming from the Delft University of Technology in Netherlands. In this paper, it presents the state of the art of 3D city modeling in the context of broader developments such as smart cities and digital twins. And it outlines 6 challenges that must be overcome before 3D data as a platform becomes a reality. They are consistency between models, standardization, data quality, data interoperability, data maintenance, and from utopian pilots to real-world use cases. In order to allow for the development of advanced applications, a 3D city model should describe the geometry and attributes of all the individual elements that are typically present in a city, for example, building, infrastructure, roads, water bodies, etc. In addition, relevant semantic information can be included with the geometries, such as the year as a building, which year was constructed, the number of people living in it, and then construction materials. And all this important information to optimize circular, economic flows, or energy consumption. By tackling these 6 challenges described in this article, we could then take a follow major step that 3D city model indeed will become a powerful information hub that can be used for computer-based urban analysis. In fact, these 6 challenges not only apply for Netherlands or other European countries. In fact, for Hong Kong, when we develop the 3D digital map, these 6 challenges we also have to consider very carefully. The Surveying and Mapping Office of the Lands Department is the official land surveying and mapping agency for Hong Kong. We produce various types of maps and plans following the adoption of education policy in the early 1970s. The SMO has converted more than 3,000 number of streets in 1 to 1,000. And this 1 to 1,000 2D topographic map is the largest scale topographic map surveyed and plotted scale in SMO. It shows wealth of information with spot heights and contour, more than 200 map features with different kinds features were defined, specified, and presented in this map. It proves very useful to many different kinds of applications, for example, engineering, time planning, land administration, and industrial purposes. So if we do the evolution of digital map from 2D to 3D, a number of aspects we have to pay attention. For example, we have to invite international experts in order to develop the international or national mapping standard, so as to, for example, the OGC standard. And also we have to do the market research in order to find out the state of the art or technology age on 3D mapping now available in the market. And also we have to interview the stakeholders, especially the Hong Kong industry stakeholders, focusing on the use cases, make sure the 3D digital map development is practical and could be applied in the real-world use cases. In the future, or what we call the ultimate targets of 3D digital map development, is to provide an object-oriented 3D city model with comprehensive 3D GIS database. This should be a completion of advanced 3D digital map with thousands of standardized 3D map features with intelligence and sufficient details and accuracy in the form of 3D GIS, and to support the 6 aspects of the smart city applications in Hong Kong. Of course, achieving this target is challenging, and there is still a long way to go. There is a report from the United Nations called the Future Trends in Geospatial Information Management, the 5 to 10 years vision. This shows how geospatial information and technology underpin national governments and documents the increasing role that geospatial information will play as an important part for the 2030 agenda for sustainable development of these 17 goals. This report has been authored by the Great Britain's Ordnance Survey National Mapping Agency, and this report looks in depth at the challenges and opportunities that will impact how we connect, how we manage, and how we use geospatial information over the next 5 to 10 years. A lot of insight could be found from this report. Technology in the 21st century, in particular, plays a prime role in disrupting the geospatial industry. In the past, the traditional surveying, you might see surveyors standing on the street, use a total station or theodolite with a single tripod. With the rapid changes in technology tools, a lot of modern surveying equipment and datasets that are now available and widely adopted. The latest evolution of technology has impacted the design and functions of modern land surveying techniques in a massive way. And more fresh impact is yet to come if we consider combine the increasing levels of automation like Internet of Things, big data, artificial intelligence, immersive technology, and the rise of digital twins. It is expected that geospatial data, including map produced, will be more efficient, higher accuracy, and better quality. Technology is the answer, but what was the question? It is always worthwhile heading back to the British architect Cedric Pye's famous quote in 1966, when thinking about building a smart city and what use cases of 3D map could be achieved based on the modern technology. In fact, OGC has listed the top-level use cases of city GML models, which can be divided into 5 main goals. They are archive, the creation and the use of the model for the purpose of the preservation of the former and the current state of an environment, and the visualization for generation of the views of the model environment in 3-dimensional. There is no doubt that visualization is often the best way to convey the overall nature of the model environment in 3-dimensional. You may saw a movie called Blade Runner 2049, which is display the future vision of the Las Vegas. In fact, in this film, all the 3D models created are making use of the realistic texture, which are based on aerial and OB photos. And they use a GIS to make a movie to describe the future vision of Las Vegas in 2049. And this movie also wins the Oscars for the best visual effects in 2018. So visualization is not only for just popular engagement or for doing some simple analysis. In fact, it is also for many different kinds of industries. And the third one, use case is navigation, is the guidance of the people or vehicles through a model environment. Semantic structure enables both finding and also guidance in terms of object categories that are directly meaningful to humans. And the fourth use case is the simulation. This is the real-world environment to simulate for the purpose of conducting different kinds of experiments like CFD, computational fluid dynamic simulation, relating to different behavior in terms of electromagnetic wave application, electromagnetic wave propagation, sound propagation, flooding effects, air ventilation assessment, or other physical process. And the last one is the analysis. We can use the 3D city model to do different kinds of 3D analysis, like a wheel-shape analysis, to detect the solar, electric, and heating potential, and also the line of sight, obstruction of light, partial contents, etc., etc. Generally, 3D city models appear to have been predominantly used for visualization. However, as I mentioned before, today they are being increasingly employed in a number of domains and for a larger range of tasks beyond visualization. There is a paper written in 2015, which is written by Dr. Philip Pijacki, who is a city GMO modeling expert and a graduate from the Delft University of Technology and now working as an associate professor in National University of Singapore. In his paper, he documented the state of the art regarding the utilization of 3D city models across multiple domains based on comprehensive literature study, including hundreds of research papers, technical reports, and online resources. This paper demonstrates that the 3D city models are employed in at least 29 use cases that are part of more than 100 applications. The potential use of 3D city models are in fact immense and only limited by our imagination. Consumers rely on the accuracy of the position and navigation capabilities of their mobile phones. However, we all know that multipath exists in urban canyons, especially in the Hong Kong situation. The biggest location issue is inaccuracy in dense urban areas, such as one side of the streets with many skyscrapers. Lately, Google has improved the Android's urban GPS accuracy with using 3D building models as reference for the GPS corrections and solutions exist at scale. Google's 3D mapping aid corrections is a major advancement in personal location accuracy for smartphone users when working in urban environments. This is a typical case showing that the application of 3D city models are more than visualization only. In 2012, the Lands Department has launched a 3D dataset called 3D Spatial Data, which is a set of digital data of 3D models featuring geometry model, texture map, and the textual attribute to represent 3 types of objects: they are building, infrastructure, and terrain. We have created more than 215,000 numbers of buildings in Hong Kong in 3D, and 53,000 numbers of buildings are higher than 10 meters. Remaining buildings are lower than 10 meters. And from this data set, we also create more than 200 models for the infrastructure and also the territorial 3D terrain model from this data set. Let me ask one question. Do you know how many 3D building models from this 3D spatial data set were created with photorealistic textures and represent as a miniature of the building? Are they all 100% are photorealistic or 15% are photorealistic? In fact, the real situation is less than 10% of this 3D spatial data set are photorealistic. So that means more than 19% of these 3D building models are in fact a 3D building blocks without texture. So this is the current situation. When we talk about the 3D individual building models, what we have right now in Hong Kong or in Lands Department. As mentioned, the 3D digital map, which is one of the building blocks of CSDI, is to facilitate opening up and sharing of government geospatial data. To meet the increasing needs of 3D digital map applications and better understanding of multi-level spaces of modern cities like Hong Kong, the government aims to develop the high-quality 3D digital map by phases and strives to cover the whole territory by the end of 2023. This 3D digital map project consists of 3 parts. The first one is the full-flat 3D visualization map. Second one is the 3D indoor map for 1,250 numbers of buildings. And the third one is the 3D pedestrian network. To enable the public to have an earlier perception of the 3D visualization map, Lands Department has produced an initial set of 3D visualization map produced using the aerial images taken in 2017 and 2018, which is basically a 3D mesh model. The 3D visualization map provides in open formats, including TAO, OSGB, and OBJ formats, which is now released on the Hong Kong Geodata Store for public access and free download. This initial set of 3D visualization map covers Kowloon area and also the built-up areas in the new territories. Only 20% of area covered so far from this dataset. The government aims to develop the high-quality 3D digital map by phases and will cover the whole territory of full-fledged 3D visualization map by end 2023. Let's take a look at the 3D activities from Google and Singapore. You might know that in 2010, in fact, the Google had taken the territory street view for the Hong Kong area. And in 2015, Google has produced a very photorealistic 3D map for the Hong Kong parcel area. How about Singapore? Singapore in 2016, they did 3D national mapping using the aerial orbit images. And the same year, they also do the territory, the whole country of Singapore with the street level surveys. And in 2018, they built a virtual Singapore platform with abundant 3D spatial data for different kinds of smart city applications. As Spencer just mentioned at the beginning, Singapore ranked #1 in the Smart City Index in 2020. The 3D map for the whole Singapore plays a very important role to support their smart city applications and initiatives. This data set they have already created in 2016. So 3D map is in fact for the digital twins is a kind of DNA or backbone and provide a foundation for different kinds of applications in terms of smart city applications or the digital twins contribution. In Germany, the capital city, Berlin, they have created more than 550,000 number of building models with semantic information. The whole city area covers 890 square kilometers. And the 3D models were created based on the aerial images. And in Netherlands, the city, Rotterdam, they create 205,000 buildings and bridge models, which are using the LiDAR point clouds and the building footprints and built as a City GML 2.0 standards. These 3D models were integrated from various sources while maintaining geometrical, topological, semantic, and appearance attributes. In Singapore, the Virtual Singapore scheme, which is a $53 million project. This is a data-rich live digital replica of the actual city, a dynamic 3-dimensional city model and cooperative data platform, including a 3D maps of Singapore. The main purpose of this Virtual Singapore is to help officers to make the best urban planning decisions and communicate with citizens by sharing information visually in 3-dimensional. They also integrate the data from government agencies, information from IoT devices and the sensors, various 3D formats provided, including the City GML format. And in Switzerland, which is a unique country and one and only one country so far to have switched entirely all the data to 3D for its national object-oriented topographic database. According to the Swiss Federal Office of Topography, Swiss Topo, they spent 10 years to build an object-oriented topographic database in 3D, with the last objects having been completed in 2019. And according to Swiss Topo, they just think that this 3D all country 3D object-oriented database creates low extra cost and only extra and many benefits for them. And how about mainland China is doing in 3D map? In fact, in China, a number of many China main cities have already created 3D photorealistic models. So from the advanced perspective point of view from Lei Deyan, Professor Li, who is a very famous expert in photogrammetry and remote sensing in China, he thinks that, in fact, in China, it's all mature enough to develop the whole country 3D photorealistic model. So the whole country, the area is covered 9.6 million square kilometers. He thinks that this is a good time to build the whole country 3D photorealistic models. So you could see that Berlin, Rotterdam, and Virtual Singapore Platform, Switzerland, all they build a very territory-wide and city-scale 3D models starting from 2015 and also including the Shenzhen in 2020. So how about Hong Kong? You may all know that a masterpiece painting by a very famous French artist, Paul Gauguin, created in 1898, more than 120 years ago. His painting is in fact reflect the situation of our 3D digital map. So what are we? Hong Kong is lagging behind other major cities, especially those cities from advanced countries on its path to build a 3D digital map. So where are we going? Could we paint a rosy picture of the future for Hong Kong 3D digital map? And are the roads ahead are winding for us? Are the light years are binding? Or do we have to adopt the philosophy, causing the weaver by freeing the stone when develop the 3D digital map? In fact, we could learn the well experiences from others, knowing their strengths and weaknesses. The 3D digital mapping standard and specifications of different regions I just presented before could provide a very good reference for us, and we could make reference for them to identify potential gaps and also the opportunities for enhancement on our current 3D digital map technological trends and capabilities. With the policy and the budget support, we have confidence to make Hong Kong an international city of world prominence in the 3D digital map development. So down to earth, what Landsd is doing right now. From October 2020, Landsd will kickstart our consultancy services for the generation of 3D digital map for Kowloon East area. And the area of this project consists of about 27 square kilometers, including 6,000 numbers of buildings in this pilot area. We will take on board the expectation from the stakeholders as far as possible in this KE pilot project, and the experience gained will help shape the requirements for implementation in the remaining area of Hong Kong, as well as setting out the best practices. From this consultancy study, we did online interviews and face-to-face interviews. A total of 60 unique responses were collected, with more than 30 bureaus, departments, offices, and institutions have responded their comments on our 3D digital map development. Respondents have identified some of the key issues, for example, data accuracy, data dissemination, data coverage, and data update. So we will consolidate all these requirements when defining the strategy for developing the 3D digital map in Hong Kong. During these 2 years, we have met different experts. For example, we have met Dr. Philip Bijaki at OGC Singapore, and also Germany expert Dr. Dajana at OGC Singapore. And also we have with a number of China main cities, how they develop the 3D digital map, what kind of technology they are using. So these all provide a very valuable information for us when we develop the 3D digital map in Hong Kong. We have also interviewed 2 international experts, Professor Luz Boomer and Professor Kristen Hipke, who are international experts on 3D mapping to seek their advice on current trends and development of 3D digital map. Professor Luz Boomer is coming from the University of Bonn, Germany, which is one of the contributors for the CityGML encoding standard. And Professor Kristen Hipke is coming from Germany, who is the president of the International Society for Photogrammetry and Remote Sensing. Both experts comment that the Hong Kong's project is an ambitious project, but it totally tallies with the international trend for 3D mapping development. And they also point out that since there are lack of international standard for 3D data accuracy with regards to positioning for 3D mapping, it may be beneficial for the local industry if Hong Kong can share its best practice and lessons learned to the global community for furthering the development of 3D digital products. They also emphasize on the use cases and applications to make sure what we have developed is tally with the use cases in the industry and the community. We looked at European cities such as Berlin, Munich, Helsinki, Rotterdam, as well as Singapore commonly adopted OGC City GML standard, focusing on the semantics and relations of the 3D models, whereas most cities from China also address the facade quality of 3D photorealistic modeling. So in Hong Kong, what we do in Hong Kong is adopting both stringencies for these two aspects. Two aspects. We will create a 3D photorealistic model, and at the same time, we will also consider including the semantic information and align the international standard, that is OGC City GML standard. And a set of measurable street view will also be generated from this project. All human face and car plate numbers shall be mastered out in 360-degree panoramic images. And these are the MMS data we capture from our department. We give a trial study to HKUST, DESR lab, which is courtesy from the Professor Wen. They are using the artificial intelligence to detect our MMS point cloud data so that all are automatic and all features can be extracted in a very short time. This is very efficient and very intelligent. Generation of the 3D digital map will involve data capturing, data processing, and data modeling. We serve to organize and measure the best of our energies and skills to do that. The aerial photos and the on-ground capture images and laser scanning point cloud will be processed to generate 3D photorealistic models to represent the shape, appearance, and position of various types of features, including building, infrastructure, and terrain. From the consultancy study, three key strategies were identified. They are incremental, implementation, outcome-based, not output-based, and set out best practice and examples. Incremental implementation means that various aspects of digital mapping and technical capabilities can be tested out using the current years as a pilot area project before full-scale implementation. Lessons learned and experience gained from this can be carried forward into the development of other regions. So in current years, we will develop the 3D digital map into two stages. Stage 1 is to create the 3D photorealistic models, and stage 2, we are focusing on the semantic models and align to the international standard, that is OGC City GML standard. Outcomes-based and not output-based. The mapping product would address user expectation and provide deliverables to directly address the application of 3D spatial data wider by users. So the 3D digital map we provider will focusing on the use cases and not just a single product that people don't know how to use it. And more applications are shown as the following video.
Introducing the 3D applications. 3D modeling of a sale site valuation. Estimation of the solar irradiation. Transportation and navigation. Classifying building types. Visibility analysis. Estimation of shadows cast by urban features. Estimation of the propagation of noise in an urban environment. City planning and design. Reconstruction of sunlight direction. Emergency response. Lighting simulations. Air ventilation assessment. Routing. Disaster management, for example, flooding simulation. Green space assessment. Underground modeling. Telecommunication placement. Land valuation.
Set out best practice. The 3D digital mapping technical specification intends to ensure standardized and consistent quality of output using best practice standard. And this experience gained from Kowloon East's pilot project can take this opportunity to reach out and participate in related organizations for further development in various aspects of 3D related applications. So our goal is to complete the project for the whole territory of Hong Kong by 2023. And that challenge is the ones that are willing to accept, are willing to postpone, intend to do the best we can. So let's talk about the 3D indoor map. In 2020, we have done a pilot project to create a 3D indoor map for about 160 buildings. This 160 buildings was anticipated to be completed by Q1 of 2021. The indoor mapping data, including routing designed to support different potential applications. We are planning to share the test data to different users and stakeholders to obtain feedback before release of the data, which will also provide as a reference for further developing the 3D indoor map of 1,250 numbers of buildings by 2023. Major government, institution, and community facilities, for example, government offices, hospital, community halls, schools, clinics, and landmark buildings that are accessible to the public will be given priority in the list. So let's take a look of the video to show how we create a 3D indoor map. In fact, we are using the building plans. All these building plans are coming from the buildings department or architectural services department or housing department. We use this building plan to digitize into 3D form, 3D units, and also generate the 3D indoor network. And this 3D indoor map supports the navigation. Navigation enables a point-to-point wayfinding, and not only for the general public user or the general user, but also support for the disabilities or the people with visually impaired. And this 3D indoor map also supports mobile version, so that if you bring a mobile device, go into the site with the indoor area, you could do the navigation as you want. And this is not only 2D. In fact, this 3D indoor map is fully supported to present in 3-dimensional. So different kinds of 3D visualization, inquiry, and analysis for this 3D indoor map are already supported. So any attributes or related asset information related to the unit could be create a link to this 3D indoor map to facilitate different kinds of indoor map location-based applications. Of course, there are many different kinds of potential applications. For example, integration with IoT and systems. We create a 3D indoor map if the site or the building with the real-time sensor using the IoT technology, they can easily directly link the sensor with their asset information to do the facility maintenance or some other kinds of building analysis based on the 3D indoor map. Also, there are many different kinds of applications empowering all of use cases on top of 3D indoor map. For example, for the people with disabilities or the people with visually impaired, for smart mobility, for new site location-based analytics, or for the fire evacuation emergency, or for the building management or facility management to do the operating efficiency. In line with the Smart City initiative of promoting walkability and connectivity, the 3D pedestrian network was designed to support navigation services and meet the special needs of people with physical disabilities. The Transport Department's HKE Mobility mobile app has already adopted the above 3D pedestrian network to enrich mobility information.
喂喂，嚟緊放假去邊街跑好啊？
之前都係睇到人哋啲推介路線，不如今次試下自己 plan 好冇？
都好喎，但係要點 plan 啊？都唔知邊條路好跑。隨住市民大眾對地理空間數據嘅需求不斷增加，地政總署亦因而推出唔同嘅產品同服務，包括喺2020年推出嘅3維行人路路網、地圖應用程式界面同埋可視化3維地圖。市民或業界可以利用依套資料去研發唔同嘅應用程式，切合不同需要。地政總署嘅3維行人路路網絡係一套綜合香港行人路資料嘅數據集，記錄咗唔同嘅行人道路類別同資訊，包括斜道、樓梯、道路嘅高度等。另外，可以配合地政總署嘅 Map API 進行空間數據查詢，亦可以結合其他資訊，例如洗手間同埋最接近嘅運動場。藉此，用家可以輕鬆做到步行路徑規劃、查詢道路細節。若配合其他應用程式及相關資訊，可得出所需時間，甚至係所消耗嘅卡路里等資料，幫助分析運動表現。配合手機其他功能，仲可以記錄低用家嘅行走路線。雖然未有呢個 app， 但相信應用程式開發者可以幫我哋呢啲跑手揾條最佳街跑路線㗎。開放嘅地理空間數據仲有好多可能性等大家發掘㗎。
咦？呢啲3維空間嘅數據都幾得意喎，等我返去睇下點樣可以幫自己寫一個最強嘅街跑 app 先。
Remember, just a percent before a report prepared by the United Nations, the future trends. And I will highlight 3 main areas to share with you that is highly related to 3D digital map. The first one is the everything happens somewhere, the new wave of data creation. Over the next decade, the technologies and data creation methods will have the greatest impact on the geospatial industry are mobile data connection methods, crowdsourcing for real-time data connection, and social media platforms. Remember, the iPhone device is just developed in 2007, and in 2020, it is equipped with very sophisticated LiDAR scanner and could create a 3D mesh model as shown in this picture. So nowadays, this is the trend that anyone can map. And you must be imaginative, strong-hearted, and you could do everything you want and create a 3D mesh model just using a very consumer mobile devices. Second is the aerial mapping. Traditionally, we use the aerial images is equipped with larger format aerial survey cameras, which continue to play an important part in national aerial survey programs. But nowadays, the drone, the UAV technology has been a main popular trend due to decreasing costs and increasing demands for timely, accurate, and high-resolution data. Also, this UAV can equip with different kinds of sensor. For example, the multispectral sensor, hyperspectral, thermal, airborne LiDAR, or the oblique cameras. UAV can be described as the single most important technology to recognize the aerial mapping industry. Of course, you may know that DJI, which is the company at the forefront of the civil and drone industry at this distant leader. This is established in 2006, just a very small office, but nowadays they are global workforce of over 6,000 colleagues in this company. And this is highly related to HKUST because the founder, Mr. Frank Wang, is in fact graduate from the HKUST. This is really amazing. I think every HKUST alumni should feel proud of it. The third one is the terrain mapping. Mobile laser scanning, particularly vehicle-mounted laser scanning system, are in the process of becoming a newly established way in measuring rural and urban environments. Further, with the development of algorithms like SLAM and GNSS, such modeling the tunnels and indoor environment is possible. Remember a theme in 2012, this is science fiction movie, Prometheus. They are using the laser scanning flying balls, pups are used to create the 3D models, and people in the spaceship can view the 3D data in real time. Little did they know that the technology is live, and the application is real. And also, you may see this survey robotic dog called Spot. This spot now can equip with the terrestrial laser scanner mounted on this survey robotic top. This is coming from the Boston Dynamics, a company from the MIT spin-off. They have a very sophisticated advanced technology and now can also use in the surveying industry. And laser scanner mounted on robotic top becomes a newly established way, not only for overseas, but in fact in Hong Kong, CEDD, Hong Kong Government Department, have already acquired 2 spot survey robotic dog for the steep slope daily operation, which is difficult for the people to access in the past. Now they use the survey robotic dog to do this difficult task. So this is not the future trend. In fact, this is happening right now. So I think that all surveying professions, include the general public, should have an open mindset to accept this new year. In fact, otherwise, this new year will embrace us unexpectedly. Lastly, been to the final question. What is the difference between Google 3D map and government 3D map? In fact, what we are doing, what Lens Department doing, the 3D digital map is unbiased, full control of data set from content to quality assurance. I would like to quote David Henderson, the Chief Geospatial Officer at Ordnance Survey. He mentioned that authoritative, definite, and consistent geospatial data continues to remain highly relevant, which provide high quality, reliable, trust, and maintain the geospatial information for a wide range of applications, and thereby help us tackle some of the biggest challenges the world faces today and in the future. Thank you. Now I will hand over to my colleague, Michael, to talk about BIM. Michael, please.
Okay, good afternoon, everybody. I'm Michael now. I'm the land surveyor working in the BIM data management unit. My main job is to help to establish the BIM data repository to better support the BIM data sharing among departments and within the lands department. Now, I would like to share with you the Landscape's plan and development on the BIM data repository. Here is some topics that I would like to share with you in the coming time. The first is to share with you the current BIM data repository prototype. And then I will let you know our roadmap of territory-wide BIM data repository development. As mentioned by our Deputy Director, Mr. Chen, we have recruited a consultant BIM score to help us to do a BIM data repository consultancy, which define the roadmap and make some recommendations on how the BIM data repository to be developed. And I would like to share with you as advice based on the sharing of the CEDD's BIM horizontal harmonization for the BIM JS integration study and the consultant study from the CIC on the development of digital Hong Kong. His recommendations on the provision of simplified and shareable BIM and the vision of the BIM data repository will be shared with you as well. Last but not least, our new development of building plan tracking tools will be provided to you. So here's the short video showing our existing BIM data repository prototype. We have successfully input the BIM and the GS data together. Users can simply use the 2D web viewer to find out what are the BIM data available. So they can simply go to the map, click on the buildings here. It is the building from the housing department, can have a preview on the buildings. Once they want to see the details, they can switch to the 3D viewer. So in the viewer, you can see that the BIM data can be visualized easily, and not just the BIM data, it also tightly integrates with our 3D spatial data. So people can do 3D navigation very easily. Not just doing this simple navigation, some spatial analysis can be conducted in this viewer, including the visibility analysis, and the shadow simulation. From the BIM data repository prototype and the continuous data handling on the BIM, we have identified some key issues that hinder the data sharing of the BIM. Different departments use different tools, approach, and practice of handling or creation of the BIM data. So once we collect it and want to put it together, we find out that the data is fragmented. And we need to apply different tools and approach to extract, to manipulate the data. And one of the key issues is that there's lack of standardization among the data. And those problems hinder the sharing of the BIM data across the bureaus and departments, and as well as the will be one of the technical constraint for the coming integration of BIM data and the 3D maps of the lands department. Now, I would like to share with you the roadmap of our territory-wide BIM data repository. This is our conceptual diagram of the BIM data repository solution. At the front end, we will have a portal for collecting different types of BIM data from the works departments. Most of them use the native format for creation of the BIM, like the Revit Civil 3D, and a data conversion engine will be used, developed and used to convert those native format into an open format IFC. And that open BIM format will be further converted into a open GS format CTGML. Not just with the BIM data, we will incorporate other types of GIS data and put them together to create a single 3D web viewer to enable the user to easily find out what data they would like to further explore with, and then extract the data for their application. A BIM web services will be established to facilitate the ongoing data sharing and integration. Here is the timeline of the development of the BIM data repository. We'll schedule our development into 3 main phases. As mentioned previously, consultant BIM Score has helped us to work out a consultancy project to make some recommendation on how to better plan our roadmap for the development. So he will suggest some on the data standard features to be developed on the BIM data repository. Other than understanding our operational need and the business need on the BIM data, the consultants has made reference to 3 consultancy studies for making recommendations. The first one is from the CEDD on the BIM horizontal harmonization consultancy. The second one is the Digital Hong Kong consultancy from CIC. And the third one is our internal 3D project led by my colleagues Ben Fan on the 3D map. Now, I would like to give you some brief understanding on what the scope of the BIM horizontal harmonization study. The scope of study is to carry out a horizontal harmonization study to formulate and align the BIM standard under the first phase development of the Kutong North and Fenner North NDA. It will revamp the design models under the first phase development of the Kutong North and Fenner North NDA in accordance with the aligned BIM standard. Because before having this study and the guidelines, many models are developed in the design stage. So through the study, a horizontal harmonization being developed, and the design model has to be revamped according to the defined standard. And the data conversion engines will be developed to convert the revamped BIM models to share both formats to facilitate effective information exchange among works departments. To better manage on the convert and receive the BIM data, a BIM data repository will develop to store all the revamped BIM models for efficient information sharing among landscape and works departments. A BIM object library will be established for aligned BIM objects. And all these things will formulate a BIM standards for works departments to adopt for their coming future projects. Some key deliverables are included in this study, and I want to share with you. The first one, which is one of the most important deliverables, is the BIM harmonization guidelines. These guidelines address data policy initiatives at the Development Bureau and RUST departments, local professional bodies, construction industry, and GIS industry professionals. It will enable the submission, sharing, dissemination, and maintenance of the BIM models and BIM attribute across the RUST departments and landscape under the study. With that guidelines, we can easily to manipulate the data to support landscape's coming 3D digital map creation and the forthcoming 3D land information system. It form a base for the Development Bureau to request the RUST department to adopt BIM standards formulated under the study in their future projects. So for the study, we would like to have these guidelines available, and then the coming BIM models will be aligned with that standard, so we can manipulate the BIM data in a more easy way. Here is the referral of the data conversion engine. All the models in this NDA area is developed either with Civil 3D and the reference. It is a native software BIM format. It will then export to an IFC4 format, which is this industrial open standard. And then the conversion engine will be adopted to convert that IFC data into an open CTGML format. Because different users have different needs on the BIM models, they may not necessary to have the full BIM of each model. They can just, the tools can help them to select the right elements for them. So some BIM models will be extracted to a individual shareable BIM models, and that shareable BIM models will then be further converted into corresponding CTGML format. Once the data being converted, a centralized BIM data repository will be developed for centrally manage those BIM data. A 2D map and also the 3D visualization platform, which is quite similar to what you see in our prototype, will be developed to enable users to easily identify where will be the BIM model available and then extract the data for their further manipulation. A customized web applications, which include many dashboards to show some statistical figures on how the BIM data being adopted and the data upload progress. And that BIM data repository will be handed over to landscape after the completion. Now, I would like to share with you some brief information on another consultant study from the CIC on the development of Digital Hong Kong. The study's main purpose is to find the best approach for the industry to adopt the 3D digital map data to better support their construction life cycle. It will collect the 3D and BIM data use case requirements of the construction industry in order to tie in with the smart city initiatives. Some recommendations will be provided for the collection of 3D and BIM data from the different construction industry organizations. It will further develop some like POC to prove how the BIM data and the 3D GS data can be worked together to benefit on different scenarios. By consolidating the feedback from the stakeholders and the industry professional, top 10 cases are recommended to demonstrate the potential applications with adoption of 3D spatial data and BIM data to streamline the operation of construction industry. And I would like to select 2 cases to give you a bit more detail. The first one is the underground utility study and space management, and the other one is the premium assessment and property valuation. For the underground utilities situation in the current situation, the underground utility data is not really well managed, and actually the data may not be reliable, and the data format is vary, they are not standardized. So it is not easy for the contractors or any organizations to put them, integrate together to have better planning. That means they need to have extra time and cost for the planning and for doing the repair work. And that will definitely delay the construction program planning and postpone the smart city development. And based on this scenario, the consultant has made recommendations that a potential development may be considered, that is to develop a centralized data platform for sharing. With that centralized platform, the different UU users or owners can easily upload, download the data, and they can, when they have any construction project or any repair work have to be done, they can just simply go to the area they interest and download the corresponding data and perform different types of analysis, including the collection analysis. So this short video demonstrates how the data can be put together and perform a more effectively and reliable collection analysis. As different organizations are using different approach, like they adopt different legend, maybe different map or different annotations for handling their underground utility records. So a standardized format is necessary to fit in the digital data platform so as to create that centralized environment. OGC has already worked out a model called Model for Underground Data Definition and Interchange. And that model is an initiative intended to provide an open standards-based way for sharing information of the underground utilities. And that model can be considered to be implemented or make reference to it for the coming centralized platform development. Another case is premium assessment and property valuation. Land premium is one of the most financial income of the Hong Kong government, mainly. It comes from land sale, lease modification, and land exchange. Various reference data are required for the industrial practice of land premium assessment and property valuation, and those data come from different systems and in different formats. Currently, in total, the land or property owners have to go through 3 different online systems to inquiry, purchase, and obtain the property details. Land GeoInfo map can be used to get the boundary of the places. The GeoInfo map will redirect the users to their integrated registration information system online services, IRIS, established by the land registry to purchase the owner details, transaction records, and property registration number. However, the records are not really directly linked to each other. That means the users, once they access the IRIS, they have to re-input the address to find out the right records. The property information like the building age and permit occupation purpose can be further purchased from the property information online system by the rating and valuation department. Again, they need to input all the searching criteria to get the right information. So the consultant suggests there may be a potential improvement to be considered. That is to develop a 3D-based, 3D web-based property information platform. The data can be should be standardized in a more interoperable way so that the data can be easily linked with each other. When we talk about the privacy level, different access rights can be granted to different users. For the public, some basic information can be offered. And for those professional users or government users, some sensitive information can be offered, like the tax record. Now, I would like to share with you some recommendations on the simplified BIM and shareable BIM from our consultant. And you may first ask why we have to simplify the BIM models. because for the city-wise consideration, we will work out different types of application, especially for a smart city. Different types of smart application will be developed. And actually, to make the application work more effectively, some application may not need to have a full detail of the data. For instance, in the screen, you can see the road impact analysis. The ROD 100 to 200 may already satisfy the purpose. And for the zoning analysis, the ROD 100 already fit the need. So if we simply provide only the ROD 300 or 400 data, it will make the applications operating in a more inefficient way. So it is recommended to simplify the BIM models into different ROD to support different applications. So another example is that, for example, when you're doing the construction work, we may want to have some tracking on the workforce. Again, we don't need to have a full BIM data to make this operate effectively. We can simply select the information in terms of geometry and informations to perform the tracking. And for instance, performing the electricity consumption analysis, again, we don't need to have the ROD 300 because the analysis time may be too much and the result will be not significant when comparing with the low ROD. So we can simplify the ROD 300 with the conversion tools to ROD 100 and then perform the analysis. The recommendations also apply to the top 10 cases that work out in the CIC consultancy study. You can see that the top 10 cases can be applied with different ROD level. Now I would like to share with you the recommendations on the BIM data repository development. Timestamp information is essential for making right decision. So the consultant recommends us the BIM data repository to be developed as a 4D-based decision support system. With that system, we can link up with different types of data, including the growth of population, jobs, construction workers, energy demand, etc., to have better planning and to get a more insights on the city issues. So the government leaders and the city planners can establish a better mid to long-term strategies. This is video showing a proof of concept developed by our consultant to demonstrate the value and power of the 4D-based decision support system. So you can see, again, in the construction sites, we can have an understanding on what construction will be developed first and what will come in, and the dashboard at the sites demonstrate the impacts to like the population, the water demand, or the number of construction workers need. So we can understand which stage will be more demanding, for example, more demanding of the number of workers, so we can have better resources allocations to address the needs. And this is the vision of the BIM data repository. So one of the key things is that the platform should be developed based on the open technology that is run on the open BIM and OpenGIS data. The key question now is that the government agencies hold the key to the data and it don't really need to rely on a particular technology. It is a technology neutral environment. Of course, we understand that different parties will make use of different tools like the Revit, Civil 3D, or ArchiCAD to create the BIM data. So that original data source should be well managed and maintained. But we have to ensure that those native data can be converted to an open format without any data loss. So that we don't need to stick to a particular technology, and we can keep evaluating and adopt the right thing, the right tools for the right job. And the whole platform should be scalable, shareable, and serviceable. What's that mean? The scalable is, that means the system can be easily scaled up to support different users or different noding. And the data, again, because we are adopting an open format, so it is easily shared with each other. And we will adopt a web services approach to make the data and the context being easily shared between different applications and systems. Open standard is not new to the global practice. Actually, in different countries, they adopt open standards for managing the city's informations. Like the U.S. General Service Administration, they accept and adopt the IFC format to support different types of operations like the space program review, circulation and security review, and some cost estimation. And as mentioned by my colleague Ben Fan, Netherlands has adopted open data, including the CityGML and IFC, to create the digital Rotterdam. And for the Estonia, they accept and use the IFC data for the BIM-based building permit check. So the open standard is being widely used in different countries. As mentioned, we have scheduled our whole development into 3 phases, and I will give you more information of each phases. The first phase is to develop a cloud-based BIM data repository. Putting the BIM data repository system on a cloud environment, it will ensure the system scalability and sustainability. It also enables the BIM data to be easily shared and collaborate with each other. In the traditional approach of handling BIM data, it will deal in a file-based approach. And we would like to go further to make the BIM data to be managed in an object-based approach. With that approach, can easily support the integration with GIS data in a single environment. Here is the conceptual diagram of the BIM data repository solutions. On the left-hand side, it's the raffle is quite similar to the BIM harmonization, horizontal harmonization project. That is to receive the different types of revamped BIM models through the data conversion engine to make it to convert into the open BIM IFC formats. And now we would like to, in our BIM data repository, we will further manipulate data by converting the file-based BIM data into an object-based approach. With that approach, we can easily to do the data validation, query, extraction for the common 3D maps. And the BIM data will be further converted into the OpenGIS repository that is in CityGML format. And these 2 data repository will work together and create a 3D GIS, single 3D viewer with consolidating both BIM and GIS context. And all this content can be shared in a kind of web services to facilitate the common data sharing and integration. Phase 2 will be the creation of the 3D map with the BIM. As mentioned, the BIM, we already get the skill set and how to manipulate the BIM data and extract the BIM data in an object-based approach. And we can make use of these elements for the creation of the 3D maps. We expect that the process can be automated and streamlined so that we can speed up the creation of the 3D maps. The BIM provides a very rich context of the construction of the buildings. But actually, when we want to create a 3D map, we don't need to have all details information. So we have to make some simplification to it. So in the diagram, you can see that the source BIM provides very rich high detail information. And you can simply simplify some, we can eliminate some elements and then make it more lightweight and simple. And that model or simplified model is already enough for us to create a 3D map or indoor map. With the 3D digital map combined with the BIM context, ensure that it will be beneficial to the construction life cycle in different stages. Starting from the planning and design stage, they can use the data to support the feasibility study. During the construction stage, they can make use of it to perform like some optimum route finding or do the progress monitoring with the integration of IoT and UAV. And for the operation and maintenance, they can make use of the 3D indoor map to perform the inspection and asset management. In the phase 3, we will develop the BIM API to make reference to our existing map API. With the map API, users now can easily use our 2D map data, and the coming will be a 3D map data. And we would like to take the same technology apply on the BIM. So we use the API protocol to facilitate the sharing of the BIM context. And we understand that to work with BIM, some different advanced tools may be need to manipulate the BIM data. But with the BIM API, the developers do not need to have tools, sufficient knowledge and tools on handling the BIM. They can simply use the API to get the context they want and create and develop any innovative applications with the BIM context. So here's the example. In the central, you find out there's a very rich data BIM models, but the users may only want to extract or maybe interest in particular elements, like they would like to get the walls or they get the floors or stairs. And through the web API, they can do that by just passing their request to the system, and the system will just return the right elements to them. Here are some potential use cases of the BIM API. You can see that they can use the API to do the facilities management, energy consumption analysis, etc. So we think that these three phases are collect together to create a digital twin of Hong Kong. Starting from the phase 1, we established a centralized BIM data repository for collecting all the BIM records. We then put it into object-based approach. In the phase 2, we make use of BIM data to create a 3D map elements. And in the third phases, we further extend the adoption and sharing through the BIM API. Now, I would like to share with you the new development of building plan tracking tools. Currently, Lands Department received the electronic building plan data in CAD format from the authorized person of the developers. With the BIM technology, they now will use the BIM to create a general building plan and making the calculation of the gross floor area. And they could submit the BIM models as supplementary information to the landscape. Our building plan unit is developing a new tracking tools to facilitate the checking and approval process respect to these requirements based on the BIM data. And as mentioned, the BIM data will be a great source for creating or updating our 3D map. And these tools will help us to easily extract the data that we need. Here is the project program of the building plan tracking tool development. Actually, this project is a joint development between Lands Department and Buildings Department. Currently, it is in tendering stage and is targeted to be awarded in March this year. And the first phase will likely to be started in March this year and complete in June 2022. And phase 1 will focus on the requirements of Lands Department. And 2 major deliverables will be provided. The first is the new practice notes and BIM data guidelines. And the second one is tracking tools in form of BIM software plugin. Two plugin tools we will develop. One is for Revit and one is for ArchiCAD. In the second phase implementations, it will likely to be start on March 2022 and will be complete in June 2023. And it will focus on the requirements of buildings department. And we expect that the newly generated practice notes, guidelines, and their tracking tools will be free to share to the developers so that they can make use of it to perform their submission. Here is the high-level concept of the new building plan tracking tool. As mentioned, a new practice notes and BIM data guidelines for regulating GEP submission will be delivered, so the developers can make use of the guidelines in preparing their submissions. A plugin tools allow them to check before the submissions on whether there is compliance to our requirements. So we hope that with that deliverables, the process and the checking can be more smooth and the time will be reduced. So today we have shared with you the CSDI, which is the foundation and framework for managing the spatial data. The 3D digital map is to provide a realistic and accurate city model for the whole city planning and application development. And the BIM data repository will provide a rich context on the BIM to better support the construction industry, and would like to provide more information to the community to develop different types of applications. And these the components connect together and work together to better support our community to develop different types of smart city applications. And we hope that we can get more feedback from the community so that you can have your advice like Hong Kong UST and academic organization give us any innovative idea and advise how we can better do our job and then to better support to smart city development. Thank you.
Well, we really appreciate this team of three, very informative, and I'm very excited to see we are moving forward in a very fast manner. Hopefully in 2-3 years time, we have much more 3D maps and data to work with. With that, I open the discussion to the floor. Anyone from the audience would like to ask any questions? Or you can type in the chat if you prefer.
Maybe let me start the question first. Yeah, thanks for the very informative seminar, and then thanks Spencer, thanks Ben and Michael. I think we actually have discussed this one offline already before that, and then this is a very aggressive initiative. As mentioned, in fact, it is a very large scale. And then like Switzerland have taken 10 years to finish the whole 3D model. So I think you've mentioned that the two main side here, one is how to generate the 3D model. One is how to distribute the 3D model for people use. Okay, so for the, I try to keep it short is for generating the 3D model, it seems there's a plan of 4 years for the whole Hong Kong. And for the B model, would the 4 years be enough? And then would there be some priority about what kind of models will be generated first? And then for how to use the B model or how to use the 3D model, and there's some examples like Zurich, etc. They use the 3D model for air quality, etc. But how do you plan to use the 3D model, distribute the 3D model to the public so that they can use them, or at the very first moment will only distribute to the government departments, So what was the roadmap for distributing the model? So many two questions. Would 4 years be enough? And then how to distribute the model? Is it by phases to different people or what?
Maybe I give some broad view answer on this question first, and then Michael and Ben also supplement. In fact, we have a more regarding a 3D digital map, and also the BIM data repository, and at the same time we built these two. I think we have more definite timetable on those 3D map, digital map, because we commit to do this, commission to do this with a budget allocated, and we would have a 3D map developed in 2023 for public use, and basically is at least is a building base, individualized building base with photorealistic texturing on building individual building blocks, and then further with an example of 1,250 building with example of indoor more simple geometry, and this time frame is more definite, and how we share with the public like what we already did in a map API, and also on a release of the mesh model, which is a continuous photorealistic layer of data on the geodata store. And in future, we would have our CSDI portal via this may share the open spatial data more in a more convenient way. And how and then about the BIM data repository, and even build up a open BIM platform, and even a BIM API is a more far-reaching one, because it involves much more works department, and the BIM standardization is not a easy role. I think tentative we would like to have such schedule as recommended by our BIM consultant, BIM score. I hope we could catch up with this schedule, and I think CIC Professor Jack Chen also work on this project, so we always have opportunity to communicate with each other and learn how to proceed with this. Maybe I pass it on to Michael or Ben Fan if any supplement on my answer.
Thank you, Jack. And the first question is 4 years, is it enough? I think that it is very challenging, but in fact, we have done in-depth market research. So we know that there are many different kinds of potential suppliers to produce high quality of 3D digital map. Some are doing in a very efficient way, very automatic, and some are doing just a manual processing. So we would like to, we hope we could find some very competent potential suppliers to do the contract for our 3D digital map, so that within the 4 years target, I think that these competent suppliers could generate a high quality 3D digital map for us within this very short time frame.
This is Alex Ju from Lens Department. I would like to make a very quick supplement to Ben Chan's comments on how to distribute the data to the public. In fact, as you may notice, the 3D digital map comprises 3 parts. The last part, the 3D pedestrian network, we have completed, and then we have distributed the data through the geodata store, as well as sharing the data through partners like Transport Department to to provide services to the public through an app. So I think in the coming products like a 3D indoor map as well as the 3D digital map, I think we will use this incremental approach as well as to deliver the data through the web services to the public. Thank you.
Yeah, thank you. So my question mainly to highlight how much work actually can be done and how much work actually has been done by Landsty. And I do appreciate the great effort. It's really significant and amazing. And I also, frankly speaking, I've discussed with Dr. Kelvin Kemp just a couple of weeks ago, and then and just mentioned about this one as well. And then I do appreciate you try to work on the open standard, open beam, open GIS. This is a very brave direction, but I think it's a right direction. Thanks.
Thank you.
Okay, any other questions?
I think academic support is important in this area. In particular, those standards is still evolving, and LOD3 and also BIM integration. Yeah, we look for collaboration in future and learn from academic. Yeah.
I just have two quick questions. Are those procedure to convert to 3D automatic or mainly by manual, by hand instead of automatic? The second question is, will those 3D maps be free to the public without having them pay for usage?
Government policy is to open data, and tentative, we would open up our digital map this year. 2021. We already got some policy support in this area and is doing some groundwork. Having revamping our system and to release the data effectively, because the map data is quite a huge size of volume, so I think follow this path. 3D map would also be free for use by the public.
Okay.
Yeah. And sorry, and the first question is about
when you have such aggressive plan to move everything to 3D, can you do the conversion automatically, or do you use a lot of manual kind of conversion from CAD to 3D?
For those indoor building, indoor part, Ben Fan demonstrate we have some work on digitizing some paper building plan or CAD format, change from CAD format and create a 3D one. And I think it's most important is we just could be able to commit. We would build 1,250 building, and you know that Hong Kong would have 600 building. High tall building, and regarding those small one like small house in the NT area, it could make up to more than 200,000 building blocks. So we could not do many of them. We just demonstrate an example, and what we got the funding is called a sitting fund to do the example. We hope we just illustrate the concept, and in future, while the technology facilitate the conversion from BIM to a 3D map, it would the roadmap would go faster, and we also anticipate those building plan GFA checking would help speed up this and help developer willing to adopt the same format of building plan submission in BIM, and is in future facilitate those for building up a 3D map for Hong Kong. Yeah.
Okay, thank you. Any other questions from anyone? So someone asks, the 3D modeling is very impressive. May I know how do you extract the data for underground structure and foundation? By some as-built record drawing or some laser scanning, etc.
Alex may, as Alex is here, could you elaborate something on what utility information base we are working with Works Bureau? Yeah.
Yes, that's okay. Thank you for the question. It is a very good question because as most of you may aware, the underground information in Hong Kong is quite piecemeal, I would say, and not complete because they are separate or distributed in different parties like utilities and also different government departments, and then most of them they are in 2 dimensions. So what the Lands Department or the government is working towards is that we are trying to standardize the data as presented by Michael. The first step is to standardize them such that they can, all the parties concerned can contribute the data in a standard format. This is our first step. And then the second step that the Lands Department will set up a underground utility database. How the data will come from, some of them will come from the as-built record drawing. When the roads are open, the contractors will scan the data, and then we've got the scanning point count to build up the database. That's the first part. The second one is we will use the existing drawings from different parties to set up an initial database. You may aware that in the example presented in the PowerPoint about the Rotterdam, the situation is similar to Hong Kong. In their database, they have some data there that are very detailed with 3-dimensional dimension and also attributes, but some of them they are in 2D. They will use some the prediction or criteria to make it a 3D data. So we will follow this approach more or less. That's the way we are trying to build up the database.
So one more question. 3D modeling is great. For city modeling, information such as building use purposes, envelope materials are also needed for building energy simulation. Will this info be available as well in the future? So asking about the material used for the envelope, building envelope, so they can do energy simulation, building energy simulation. So will those information other than texture, the look and feel, but also the type of material used, will they be coded in the 3D?
It's always one of our prime purpose to build a 3D map cater for works, in particular those AEC, architectural, engineering, construction purpose, and including building energy saving system, hosting of IoT sensors, but how our geometry model could accommodate these tagging of sensor information on the system. I think we still need collaboration with those telecom people or building service people, engine works. So this is our most concern. We have interviewed different stakeholders soliciting their views on how we build our 3D map. We will not satisfy on just visualization, but in terms of the accuracy of the building and how other facility can tap on this model is one of our most important concern. We hope just like our two-dimension 1 to 1000 basic map, in future our 3D map could also be the most important basic map for Hong Kong, in terms of various kind of application for different sectors. So that's why your opinion and your suggestion are most welcome. Before we fully develop or design the format and scale. And we now what we proceed now is we start our Kowloon East pilot consultant, and I think in the coming couple of months, we would our consultant would together with us to let some contracts in building the real data of Kowloon East, and this is the first one. And with this consultancy and contract, and with lesson learned, we would construct our second one, which is quite step by step a bigger consultancy. And we hope before we start the bigger one, we could learn some lesson from this first consultancy, which OVR is our consultant, and with contractors to be awarded in the coming few months, and learn from these, and to fine-tune our design on 3D maps, and that's why comments and suggestions from multidiscipline are most important to us. Yeah.
I think once the data is available, it will inspire many different types of applications, and they will add, can you do this and that? They were asking for more attributes to be added. I can see that coming. For the building energy people, they think about, can I do energy simulation? That will require the materials used in the building envelope. And then maybe that will inspire other applications that ask more or add different kinds of attributes. So I can see that coming. But it's a very good start, I think. So people can already see the importance and the value of using it for various kind of purposes. So that's what Zhong Ming is asking, actually.
Yeah, I understand the user requirement come from multidiscipline. We cannot entertain all, and I think just similar to our 2D map, 2D topographical based map, we just gather user requirement and do those most discipline required information, and limit to a certain extent the definition of our 3D map, and for some small group requirement, we just leave it to those specialized group to do the remaining part, and we hope those specialized application could tap on this system and or make use of some map API function to share data with each other. But I think the technology would lead us to this role in future. Yeah.
Are there any other, maybe one last? I don't want to hold them for too long.
Sorry,
2 hours
on this. Yeah.
It's a very, very long 2 hours on the speakers. I'm sure we learned a lot from them. One more, last one. May LANSD consider to collaborate with MTR to adopt digital twin related technologies to expedite the coming railroad development projects? May the experiences of KTN and FLN NDA be applied to the development of other NDAs in Hong Kong?
In my part, I have shared one Works Department technical circular on BIM adoption. If you read this circular, it's also mentioned about some entrust works agents like MTRC and some other like URA, those closely government bodies. They also are advised to contribute their BIM model to form a comprehensive BIM data repository for planning, lands, and works application. So we would follow this, but you would read the circular that is as far as practicable, and we would you see it all depends on how the Works Bureau lead on this and how commonly BIM sharing is the trend and concept accepted by all parties.
Yeah, okay. I think it's a very good 2.5 hours. Thank you very much. I hope in the future we'll invite you back for more updates. I know it's very exciting for me.
You look for everything after this one.
Yes, maybe a year later or a year and a half, we invite you back. So we are very excited to learn from you. Thank you very much for your time and for the 2 hours, 2.5, more than 2. Thank you.
Thank you for
Thank you.
your invitation. Yeah, thank you.
Okay.
Thank you.
Bye-bye.
Bye-bye. Bye-bye.
Bye-bye.